Hello everyone. Now we are going to see the disk organization. That is the physical structure of the disk. So in this, a physical structure of disk is memory storage device which looks like this. So we can see the diagram in this physical structure we can see. Now uh, first point is hard disk consists of number of platters. The platters rotate at a very high speed, that is 5400 revolutions per minute to 10,000 rpm. Disk read and write heads move over the platter surface to read and write data bits. Means with the help of headers, or we can say head of this head, that we can see here, head 0 and head 2 is shown in the figure. With the help of these two heads, we can perform the operations like read and write on the disks, that is bit by bit. Now, the disk head can read or write data only when the desired disk surface area is under the disk head. Means both these platters will revolve around this spindle, and the heads also continuously moves on that platters. So in this way they perform the read and write operations. Read write that is RW head moves over the rotating hard disk. It is this read write head that performs all the read and write operations on the disk, and hence position of RW head is a major concern. To perform a read or write operation on a memory location, we need to place the read write head over the position. Some important terms must be noted here. First term is seek time, the time taken by the RW head, that is read write head, to reach the desired track from its current position is nothing but the seek time. Second one is the rotational latency, is nothing but the time taken by the sector to come under the read write head. Yes. Uh, the platters are divided into sectors, and uh, yes, so the time taken for the sector to come under the read write head is nothing but the rotational latency. Third term is data transfer time, means that is the time taken to transfer the required amount of data to that particular file, to that particular disk. It depends upon the rotational speed. Next term is the controller time, the processing time taken by the controller. Means processing time is nothing but the time which is required to write or read that particular data from that disk or to that disk is nothing but the data transfer, or we can say controller time. Next is average access time. Average access time is equals to seek time plus average rotational latency plus data transfer time plus controller time. Now, next part is logical disk structure. This is our physical disk structure. Now we are going to see the logical disk structure. The disk is divided into tracks. The platters are divided into tracks. each track is further divided into sectors. So we can see in the diagram that is sector 1, sector 2, sector 3, dash dash up to SN, that is nth sectors are shown in the diagram. So point to be noted here is that outer tracks are bigger in size than the inner track, but they contain the same number of sectors and have equal storage capacity. So we can say that the outer tracks are larger in size, but the capacity will be same for inner tracks also and the outer tracks also. So this is because the storage density is high in sectors of the inner tracks, whereas the bits are sparsely arranged in sectors of the outer tracks. So space of every sector is used for formatting. So the actual capacity of a sector is less than the given capacity. So some space is utilized for the formatting. That's why actual capacity is lesser than the given capacity. So next point is basically hard disk can be divided in the logical structure in the following five logical terms. So if we are going to see the logical structure of any disk, then we must refer the several logical points or we can say logical structures in the following logical terms. So first term is MBR, that is master boot record. So first of all we have to maintain the master boot record so that we can um, store or we can say load the operating system on a particular disk or in system. So what is the master boot record? What we are going to store with the help of master boot record at the beginning of the hard disk. At the beginning of the hard drive is the MBR. First, we have to store MBR in our system. When your computer starts using your hard drive, this is where it looks first. So, whenever our computer system is going to start, so it will look for the MBR. Then MBR itself has a specific organization. The size of the MBR is 512 bytes. The bootloader is the first 446 bytes of the MBR. Means if the MBR is of 512 bytes size, then in that bootloader is the first part and it will occupy the 446 bytes of MBR. This section contains executable code, and in this bootloader we are going to store the executable code where programs are housed. Now, the partition table are four slots of 16 bytes each. So there are four slots of 16 bytes, that is for partition tables containing the description of a partition on the disk. Means it contains the information about the partition on disk. So this is the partition table which is in the MBR. Here is how to describe a partition. Now, there are four slots of 16 bytes, and these 16 bytes, how we are going to refer. So, we will see. So, here is how describe a partition. State of partition means first of all we have to specify the state of partition. For that purpose, we specified 1 byte, and that is inactive partition bootable, or what is it active partition bootable. So next one is custom heads at the beginning of the partition. So this record, that is heads, means beginning at the beginning of this that partition, address of that particular partition we have to store. That is nothing but the custom heads at the beginning of the partition. That uh, information we are going to specify with the help, means using 1 byte space. And then as next point is cylinder sector and the beginning of the partition. So cylinder sector, now yes, we have to manage the cylinder number also on we can see cylinder sector. That information we are going to store at the beginning of the partition with the help of 2 bytes. Type of partition, which type of partition we are going to store, that is file system, example FAT32 or X2. Then this information we are going to store with the help of 1 byte space. And next point is head of the end of the partition, that we are going to store in 1 byte. And cylinder sector and the end of the score, that is of 2 bytes. The number of sectors between the MBR and the first sector of the partition, that is 4 bytes. Number of sectors of the partition, 4 bytes. This is about the 16 bytes. The magic number is 2 byte, used to determine if the hard disk has a bootloader or not. If it does, the magic number should be equal in value to hexadecimal. So that is 55AA. Now DOS boot recorder. Next, after MBR, that is master boot record, we will maintain the DOS boot record after the partition table. Means after the partition table of the MBR, we are going to maintain in our disk space the DOS boot recorder. Uh, the DOS boot record, or sometimes called DOS boot sector. This is the second most important information on your hard drive or hard disk. The DOS boot record for the first partition on a hard disk is usually found the DOS boot record for the first partition on hard disk is usually found at absolute sector 63, the 64th sector on the disk drive, or in CHS form. We can say CHS equals to 0, 1, 1 for most drives. So these values are we are going to refer for CHS, that is 0, 1, 1. The sector on which DBR resides become logical sector 1. Whenever we are going to store this DBR, it is logically sector 1 of that particular partition for the DOS. The sector number used by DOS starts from physical sector on which the DBR is located. The first sector number used by DOS starts from the physical sector on which the DBR is located. The first logical sector of each DOS partition will contain a DOS boot record or DOS boot sector. The job of the DBR is to load the operating system from the hard drive or hard disk into hard disk drive into the main memory of computer and give the system's control to the loaded program. So basically, DOS would record will load the operating system from the hard disk to the main memory. So that is about then file allocation table. And next part on the hard disk will be for the system will be FAT, that is file allocation table. Following DBR, after DBR, the file allocation table. The FAT has been modified several times to accommodate expanding needs. Means it can be modified or we can say expand according to the need. FAT keeps a map of complete surface of the disk drive such that which area is free, which area is bad, which area is taken up by which file. That particular record has been maintained with the help of file. When some data stored on the disk surface is to be accessed, the DOS consults the file to find out the area on the hard disk surface that contains the data. The file does not keep track of each and every sector on the disk surface. Instead of it maintains the disk area in a group of sectors called clusters or a location unit. See the cluster discussed in the chapter. Okay, instead of keeping a track of each and every record, the FAT systems uses the cluster. A cluster is the smallest unit of hard disk drive space that DOS allocates to a file. It consists of one or more sectors depending on the drive size. So means there are several sectors are in the cluster. The cluster size is decided and fixed by the DOS format program during the high-level formatting of the hard disk drive. See the size of cluster discussion. Actually, the FAT is an index of the clusters of the entire module. Yes, all the clusters information has been recorded in this FAT. The FAT has one entry for each cluster. The first two entries in a FAT contains the information about the FAT and the third subsequent entries in the FAT are assigned to cluster of disk space, starting with the first cluster available for use by files. Now next part will be that is root directory and directory table. So following the FAT, last FAT is the boot directory. Means after this we are going to specify the root directory or directory table. So the root directory is like a table of content of the information stored on the hard disk drive. The location of the root directory can easily be established by adding up the values from the boot record as it is positioned following the FATs. The directory area keeps the information about the file date and time, the file creation, file attributes, size, and starting cluster of the partition file. Each directory entry describing this information about a file is a 32-byte information. The root directory contains the information about the files and directories branching from the root directory. All further directories are themselves stored as files in the same format as the root directory.